Okay, this is absolute value part 2, and what I'm basically going to do is continue on what we did last time, but with a slightly more complicated example. So I'm just going to write down what the function is that I'm going to attempt to graph, and I'm also going to do a piecewise analysis of this absolute value function. So we have absolute value of 2x minus 6 plus 1. The first thing I need to do is create some points that I can plot so I can get a picture of this thing. So I'm going to use the table of values approach, and I'm going to show you a little trick here as a way of locating the vertex. But first, you're just going to have to trust me why I'm picking certain points. So I'm going to pick the points 2, 3, and 4 as x values, and I'm going to explain my reasoning behind that in a little while. But first, let's just figure out what the y values would be. If we plugged in the 2, we'd have the absolute value of 2 times 2 minus 6 plus 1. Now this would be 4 minus 6, so that would become a negative 2, but remember, you're absolute valuing it. So that becomes positive 2 plus 1. So it looks like the y value is 3. Okay, so I'm just going to clear this away. And, okay, and then we got some room for our next x value that we're going to calculate. We're going to put in a 3. Oh, I've lost my function here. Okay, I'm just going to rewrite it. Absolute value of 2x minus 6. Plus 1. Okay, so we're going to plug in 3 this time. Now you're going to get 2 times 3 minus 6. Oh, look at that. I'm going to get 6 minus 6. And even though I'm absolute valuing it and all, this is going to be 0 plus the 1. So it looks like I'm just going to get a y value of 1. Okay, before I clear everything away this time, I'm just going to write it on the underneath here. So we're going to plug in the 4 now, so that would be the absolute value of 2 times 4 minus 6 plus 1. So this is going to be 8 minus 6. So this is just going to be 2, and of course the absolute value of that just leaves it alone. So we're still going to get 2 plus 1, so we have a y value of 3. Okay, now I'm going to clear all this, everything except my table of values away, so I have room for my grid. So hopefully I don't clear away my table. All right, good. So let's paste in the grid here, and now we're going to start plotting these points and see what we have. So we have the point 2 to the right and up 3. All right, there it is. Then we have 3 to the right and up 1. And then 4 to the right and up 3. Now you can see this is sort of forming that V shape, which is so typical with absolute value graphs. So we have the line on the right side, and we'll have the line on the left side. Okay, I'm going to put in the arrows indicating it goes on forever. All right, so there's my graph, and I'm just going to make a little note. The very important point is the vertex, and you'll see that, oh, the vertex is at 3, 1. And for domain, I have all real numbers, and for range, I have y values that seem to be minimum of 1 and bigger than that. So y greater than or equal to 1 for my range. Okay, now how did I know that 3 seemed to be a very important point? And then I went 1 to the left and 1 to the right so as to form this little V shape. Well, let me show you. Let's clear the screen and look at the original function yet again. So it was absolute value of 2x minus 6 plus 1. Basically, I look at the part that's inside the absolute value, and I try to make that equal to 0. And that's the trick to finding where the x-coordinate of your vertex will be. So I would go 2x minus 6. I want that to equal 0, so I'm going to add the 6 over to the other side, and then divide by 2. So that tells me, oh, my vertex will have an x-coordinate of 3. So then I go, okay, now I know that's going to be where my vertex is. Wouldn't it be nice to get a point either side to kind of get that V shape? And that's why I picked 2 and 4. Okay? I won't recreate everything else, but that was my secret to how I knew to kind of use the 3 as my kind of central point. Now, the next thing that we have to do is a piecewise analysis of this thing. So let's clear the screen and use the following approach for our piecewise analysis. So we know that this is our absolute value function, absolute value of 2x minus 6 plus 1. So the piecewise approach, on the one hand, I would be thinking to myself, well, what happens when these x numbers are on the left side of my vertex? So they're going to be x numbers that are less than 3. Well, if you put in a number that's less than 3 into this equation here, into this function, you're going to get numbers, actually I'm just going to give myself a little more room here. I kind of squished myself up here. So let me just delete that, and it's going to rewrite it with a bit more room. So we're working on the left side of the vertex. If we look at a number that's on the left side of the vertex, like say 2, if you plugged in 2 times 2 minus 6, okay, what's happening here is that these numbers inside your absolute value sign are going to be negative numbers. And that's because you're going to get 4 take away 6. That's going to be a negative number. And that's true of any of these numbers when x is less than 3. So how do we simulate this and not have absolute value symbols there? Well, we know we're going to get negative numbers, but we want to turn them positive. So what I'm going to do is this. I'm going to take these negative numbers, 2x minus 6, but I'm going to put a negative sign in front of them. And that's going to turn these guys positive, which does exactly what the absolute value symbols are doing. So this is basically my equation. I'm just going to clean it up a little bit now, expand out the brackets. So this would become plus 6 plus 1. And then if I can combine the numbers, I'm going to have y equals negative 2x plus 7. And that's when the x is less than 3. Okay? Now what about when x is greater than 3 or equal to? Well, that means that the numbers I plug in, for example, say I plugged in a 5, I would have something like the absolute value of 2 times 5 minus 6 plus 1. Well, you can see this number here is positive. Do the absolute value symbols actually do anything? Well, the answer is no, because this number is already positive. I don't need any absolute value symbols. So I'm just going to leave this expression alone, 2x minus 6 plus 1. No need to change anything. These are always positive numbers already. And again, let's get rid of the brackets and combine any numbers that go together. So we're going to end up with y equals 2x minus 5. So these two equations here are doing exactly the same thing as our absolute value function. And this is our piecewise analysis. And that's all I'm going to do in part 2. In part 3, I'm going to look at a little bit even more challenging example that might involve some little extra tricks and stuff. Okay? So that's going to be it for part 2.